Hello everybody. So in today's video we are going to go over your respiratory objectives 3, 4, 5, and 6. In your last video I got a little bit overzealous and I went overboard and went ahead and already explained objectives 3 and 4. So I'm going to go ahead and do that again, but a little bit faster this time, just so you guys get a double dose of it, and then we'll be going over objectives 5 and 6. Basically, we're going to go over the basics and more anatomy stuff before we get into pressure and other important things like that today. So, objectives 3 and 4, fast information to know that help things. Objective number 4 is differentiate between conducting and respiratory zone structures. Conducting zones, those are the actual regions or tubes within your respiratory system where air is passing through the body. So this would be things like your trachea, bronchi, larynx, that kind of thing. Basically anything from your tertiary bronchi up to your nose or mouth would be a conducting zone. Right? Your respiratory zones are the parts of your respiratory system that are directly involved with gas exchange between the air you breathe in and the gas like oxygen and carbon dioxide that your blood and red blood cells carry. Right? So the respiratory zones are going to be the things at the very, very tippy end of your respiratory system, such as your alveoli, the alveolar sacs, your terminal bronchioles, and the respiratory bronchioles. Right? Objective number 3 is explain the protective mechanisms of the respiratory system. So your respiratory system has some protective mechanisms. They keep your nasal cavity is wide and it adjusts air temperature to comfortable and safe temperatures for your lungs. This would mean if you're looking at people by heritage, people who have wider noses tend to live in environments where the air is less hospitable to be breathed in immediately, right? So people with more narrow noses tend to live in environments where that's not the case. Fun fact about demographics like that, but your nasal cavity is designed to warm up and change the humidity or temperature of the air that you breathe in so that it doesn't shock or damage your lungs. When we start talking about your nasal cavity has all of the cells along it have cilia on them. And you have nose hairs. We all have nose hairs. I know some people don't like to acknowledge them, but I promise you they do exist. And the mucus and whatnot that we hate so much that may come running out of your nose occasionally, all of that serves a point. It catches the dust and germs that we may breathe in because that stuff is better caught in your nasal cavity and by your nose, where you can easily blow your nose and get it out, as opposed to giving an infection to somewhere deeper within your respiratory system as though those germs or that dust got all the way down into your bronchi. Right? So the hairs help catch things. The mucus also catches things and it lines the respiratory system to catch anything that the hairs can't. Each of these cells have little cilia or mini hairs on them, and those cilia are going to sweep the mucus that has caught all of the dust, generally speaking, toward the back of the nasal cavity where the pharynx is. And inevitably, that mucus is going to be dropped down the pharynx and down your esophagus and land in the pit of your stomach, which is a pit of hydrochloric acid. And any germs or bad things that you might have inhaled, generally speaking, are going to die in that vat of acid of your stomach. That's generally speaking how things go. You actually swallow a great deal more mucus than you believe. The reason why our noses run when it gets cold outside is our bodies amp up mucus production to help protect us, but also in the event that we get sick, like a cold or the flu bother us because they infect the cells at the back of our throat that run up your pharynx. And a lot of those cells are not the cells like your goblet cells that make mucus. They're the cells that have the cilia on them. So when we are getting sick, the cells that tend to be infected are the ones whose job is to sweep the mucus away. And if basically, it's sort of like if the janitor at your school or place of work gets sick and is out for a few days, things are going to get a little bit messier for those few days because nothing's around to clean up the mess, right? So if the cells whose job it is to sweep away the mucus are infected, things are going to get a little bit messy until those cells are well again or have been replaced by new cells that can do the job. Same kind of deal. But that's how your immune system, and you have immune system cells patrolling this region quite frequently. But that's how your immune system works with this. And your protective mechanisms within the respiratory system. Right? So, your objectives 5 and 6. We talked about your larynx in the last episode. We'll get here eventually. Right? This is brief anatomy of your respiratory zones. So brief anatomy of your respiratory zones. You have the trachea coming down to the carina, primary bronchi, secondary bronchi, tertiary bronchi are all the pretty colored ones that you see here. And yes, when you get into it, they all have different names. But you guys don't you guys will never be asked to tell me about tertiary bronchi B10C. Don't worry about that kind of thing. Just, you don't have to worry about that. And then if we zoom in closer, this is the alveolar sacs. Objective number 5 is discuss the anatomy of the respiratory membrane in terms of both structure and function. And objective number 6 is we're going to discuss the structure and function of the lungs and pleura. Right? So let's start with our big picture view of the lungs before we zoom in a little bit more. Right? So here we have the lungs, a lovely little simple cartoon of them. Right? So they are 2 large organs. You have a left and a right lung. Their job is to maximize the surface area inside them so that they can be filled with the maximum amount of airspace as possible. Right? Scrolling back a couple of slides, this is actually a microscope slide of the inside of your lungs. As you can tell, this is you have a ton of airspace, a ton of air sacs. It almost looks like a cut sample of a sponge because you have so little tissue but so much airspace in your lungs because your lungs are designed to give you the maximum amount of air carried within. Right? So your lungs are designed to be able to hold the maximum amount of air and have a maximum amount of airspace available as possible. The more air in your lungs that you can breathe in and hold, the more gas can exchange between the air that you've breathed in and the blood that's in the capillaries around it. And that means the easier breathing will be. Right? So the more air that can get in your lungs and exist there, the more gas can be exchanged and the easier breathing is going to be for you. Right? But remember a couple of details here, right? Your heart is right here. Right? Your heart leans toward the left side of your body. Right? We know this. The lungs have to compensate for that. So as you can see in this left lung, there is this area here called the cardiac notch. That is the nice little notch where the heart is because your heart leans left, so there's space for your heart here. But that does mean that your left lung is a little bit smaller than the right side. So your right lung is going to be bigger than the left lung because the left lung had to be smaller to compensate for where the space that the heart takes up. Because of that, when we start talking about the lobes of your heart or the lobes of your lungs, your left lung only has 2 lobes. It has the superior lobe, which is this top lobe, and an inferior lobe, which is this bottom lobe. What separates the 2 lobes? Right here, would be the left oblique fissure. On the right side, however, because the right side is larger, your right lung is divided into 3 lobes. Once again, you have a superior lobe, but now you have an inferior lobe and a middle lobe between the two. Your right oblique fissure separates the middle and inferior lobe, but the other fissure here seems to go more horizontally, and it is called the horizontal fissure that separates the superior lobe and the middle lobe of your lungs. Right? When we zoom in, you're going to see a lot of these lovely little alveoli and alveolus sacs, right? So if we're looking at this, it looks like bundles of grapes, right? Each one of these little grapes is called an alveolus. The plural of an alveolus is alveoli, right? And the bunches of them are called alveolar sacs. So your alveolar sacs act a lot like a bunch of balloons, where at the end of your respiratory bronchioles, and they are the last set of tubes in the series of air tubes that get air to here. And your bronchial tubes get increasingly smaller until they get to your alveoli here. As they get into the lungs, you can see that the alveoli are covered in groups of capillaries like this. Look at that lovely mess right there. So each alveolar sac has a set of capillaries and blood vessels leading to it and attaching to it, right? That because your alveoli, each alveolus here, is where gas exchange is going to happen. Because you have capillaries surrounding each little alveolus, and those capillaries are where gas exchange will happen as you breathe in and out, right? Here's a better example of your breathing pathway here. And here's another example of your terminal bronchioles, respiratory bronchioles, and the alveolar ducts and alveolar sacs with individual alveoli, or an alveolus at the end of it. So this is a lovely flow chart for how oxygen passes through your body. That would be your objective 2 from the last video. Right? But now we have to talk about another serious thing, and we're talking about tissue layers here. So your lungs have an outer layer of tissue, like an outer covering, right? That is called, the lining of your lungs is called the pleura, right? And you have a pleural cavity, right? So you have a couple of layers of pleura here. You have a parietal pleura, which is sort of the wall that attaches to your intercostal muscles. It touches your intercostal muscles, which are the muscles between your ribs and your ribs. And you have a visceral pleura, which is the literal outside of your lungs. That is the literal outside area of your lungs. And there is a small cavity in between, just like there was with your heart. And that cavity is called the pleural cavity. That pleural cavity, generally speaking, is a little bit moist in there with a fluid that helps you breathe in and out. That fluid, just like with your heart that's there, is going to protect you from friction and surface tension and that kind of thing. Because as you know, when you have moving body parts rubbing against each other, and you're not going to not have your lungs rub up against these muscles and whatnot, when you have moving body parts, if there is nothing to absorb that friction, like a small layer of liquid, it's going to have the same effect as though you are rubbing your hands together. And I don't know if you want to imagine this, but imagine you have been jogging or something, and you're out of breath because you've been exercising and pushing yourself oh so hard, and you start feeling that same heat and rubbing warmth on your insides where your lungs have been inhaling, exhaling. That would hurt. That would be terrible. I would never want to feel that. So the purpose of your pleural cavity here is to maintain pressure inside the lungs so that you can breathe. And your next video is going to be all about the pressure, like gas pressures and that kind of thing. But also to reduce friction. Right? So your pleura are the lining of your lungs in your pleural cavities, body cavities where your lung sits. And they are designed to maintain fluid levels within the pleural cavity and maintain pressure levels within the lungs, body cavity, and outside the pleural cavity. Pressure is important when we start talking about all of this. We'll get here and I will explain all of the pressure stuff in your next video, so you don't have to remember your physical science or physics stuff right now. But what you do need to know is that pressure is super important for breathing, which is why you're going to get another video all about that. Right? When we talk about pressure, we're talking about pressure in relation to atmospheric pressure. Right? That would be the pressure of the atmosphere around you. Generally speaking, atmospheric pressure is measured at 750 millimeters mercury at sea level. So that is, if you are at the beach staring at the ocean, that is atmospheric pressure for the most part. Your intrapulmonary pressure, that is the pressure that is intraalveolar or inside your alveoli, is abbreviated with a big P for pressure, ATM at the bottom. And your intrapleural pressure, or the pressure like inside the pleural cavity, or IP, big P, little IP, is always going to be negative, right? So your intrapulmonary pressure, the pressure inside your alveoli, is always going to be equal to atmospheric pressure because you are breathing in that air. Inside your alveoli is equal to atmospheric pressure. However, the pressure that is inside your pleural cavity, your intrapleural pressure, is always going to be negative. That means it's going to be less than your intrapulmonary pressure and atmospheric pressure. Pressure inside your pleural cavity is always going to be less than atmospheric pressure. Your pleural cavity is designed to maintain that. Ideally, it's going to be about -4 millimeters Hg, or mercury, under atmospheric pressure as an optimal setting. And your lovely pleural cavity is designed to maintain that. Right? So this was your little fast video. I hope this helped make some sense. We will get more into discussing this pressure stuff in your next videos, because we're going to talk a great deal about this maintaining pressure for your lungs, and why maintaining a vacuum sort of inside your lungs is also very, very important. So that's going to be an entire video for you. And what happens if it's not maintained? You'll get some cause and effect side effects of this before we start discussing this otherwise. Right? So have a wonderful evening. And I hope, if you have any questions, let me know. I hope this has made some sense to you. Have a wonderful night.